Hello everyone. In today's topic, we are going to talk about definite integrals. So area is equal to limit summation of f times c sub k times delta x from k is equal to 1 to n, where n approaches infinity is equal to the integral of f of x dx from a to b. Here's a fun fact. Leibniz chose notation for derivative dy over dx as well as integral notation. He chose to change the Greek notation into Roman letters. So let us have the parts of an integral expression. So this is the upper limit of integration. This is the lower limit of integration. This is the integrand, which we already studied along the indefinite integrals. Of course, this is the variable of integration, so doesn't matter if it's x or another letter. It depends upon your integrand. And the whole of this one, we call it integral of f from a to b. So it is read as the whole of the equation. Area is equal to the integral of f of x dx from a to b. So when we use the definite integrals, we always talk about the area. So later on, we shall solve about areas bounded by curves and lines in the next video. So there are rules for definite integrals. The first one is integral for constant functions. It states that the integral of c dx, which is c is a constant, from a to b is equal to c times b minus a. Now let us solve the power rule. So the power rule is somewhat similar to the infinite integral. It's just that we need to substitute the lower limit and the upper limit. So the integral of x to the n dx from a to b is equal to x to the n plus 1 over n plus 1 from a to b. There are other rules that we need to follow. So order of integration, the zero, the constant multiple, sum and differences, additivity. So in here, for the order of integration, if your b comes first before your a, it is expected that the result will be negative. For zero, if your lower limit and the upper limit are the same, then it is equal to 0 always. For the constant multiple, if there is a constant or a number before the integrand, then the constant will be outside, just like in the indefinite integral. So we put it outside or before the integral symbol. Then whatever the result for the evaluation from a to b, then that's the time that we are going to multiply it by the constant. So the sum and differences, so if it's plus, then we are going to add both the integral of the f of x and g of x. If it's minus, then we are going to subtract, of course. For the additivity, if we have in the first function, we have from a to b, and the second function, we have from b to c. So generally, we are just going to evaluate the integral of f of x dx from a to c. So let us have example number 1. We are going to determine the integral of 5 dx from 4 to 6. So in here, first we are going to integrate 5, which is equal to 5x, and then we are going to evaluate it from 4 to 6. The first thing we are going to do is to substitute 6, and then substitute 4. So we have 5 times 6 minus 5 times 4. So 5 times 6 is equal to 30 minus 20. So therefore, we have 10. So the integral of 5 dx from 4 to 6 is equal to 10. Before we are going to have the other examples, let us recall the power rule, which is very important. To determine the integral of x to the n dx from a to b, it is equal to x to the n plus 1 over n plus 1 from a to b. So from here, we are going to get first the integral of x to the n, and from that, we are going to evaluate it from a to b. So let us have example number 2. Let us determine the integral of x squared dx from 3 to 4. So in here, we are going to integrate first x squared, which is equal to x to the second plus 1 over 2 plus 1, to be evaluated from 3 to 4. It is equal to x to the third over 3, to be evaluated from 3 to 4. So from here, we are going to substitute the upper limit first before the lower limit. So we have 4 to the third over 3 minus 3 to the third over 3. It is equal to 64 over 3 minus 27 over 3, which is equal to 37 over 3. So the integral of x squared dx from 3 to 4 is equal to 37 over 3. Now let us have example number 3. Let us determine the integral of 3x squared dx from 1 to 2. So in here, we are going to integrate first 3x squared. So we have 3x to the second plus 1 over 2 plus 1 from 1 to 2. Simplifying further, we get 3x to the third over 3 from 1 to 2. Now let us evaluate. We are going to substitute first the upper limit. But before that, we are going to simplify. So we can cancel 3 and 3. So therefore, we have x to the third from 1 to 2. Let us substitute first the upper limit before the lower limit. So we have 2 to the third minus 1 to the third. And 1 to the third is equal to 1. So 2 to the third is 8. 8 minus 1 is equal to 7. So therefore, the integral of 3x squared dx from 1 to 2 is equal to 7. Now let us have another. So let us integrate 3x squared minus 5x plus 2 dx from 1 to 2. So we have 3x to the 2 plus 1 over 2 plus 1 minus 5x to the 1 plus 1 over 1 plus 1 plus 2x from 1 to 2. Simplifying further, we get 3x to the third over 3 minus 5x squared over 2 plus 2x from 1 to 2. In here, I didn't simplify 3x to the third over 3. So it is the same. If you are going to simplify first, it's up to you, okay? In here, I didn't simplify. So I immediately substitute the value of your upper limit. So 3x to the third will become 3 times 2 to the third over 3 minus 5 times 2 to the second over 2 plus 2 times 2 minus substituting the lower limit. So we have 3 times 1 to the third over 3 minus 5 times 1 to the second over 2 plus 2 times 1. Simplifying further, we get 8 minus 10 plus 4 minus 1 minus 5 over 2 plus 2. So simplifying further, we have 2 minus 1 half, which is equal to 3 over 2, or 1 and 1 half. But I prefer to write 3 over 2. So let us have the integral of trigonometric functions. The integral of cos x dx equals sine x plus c. The integral of sine x dx equals negative cosine x plus c, while the integral of secant squared x dx equals tan x plus c. Now let us have example number 1. We are going to determine the integral of cosine x dx from pi over 3 to pi over 2. Please do remember that pi is equal to 180 degrees. So first, let us have the integral of cosine x, which is equal to sine x. And then we are going to evaluate it from pi over 3 to pi over 2. In here, we are going to have sine pi over 2 minus sine pi over 3. Sine pi over 2 is equal to 1, while sine pi over 3 is equal to square root of 3 over 2. Subtracting it, it is equal to 2 minus square root of 3 over 2. So the integral of cosine x dx from pi over 3 to pi over 2 is equal to 2 minus square root of 3 over 2. So now let us have example number 2. We are going to determine the integral of 3 sine x dx from 0 to pi over 2. So in here, because we have a constant 3, we are going to write 3 before the integral symbol. So we have 3, the integral of sine x dx from 0 to pi over 2. Then we are going to integrate sine x, which is equal to negative cos x, to be evaluated from 0 to pi over 2. Then we are going to substitute. So negative 3. Since we cannot have the value for negative cosine, so the negative will be going to positive 3. So negative times 3 is equal to negative 3. Then we are going to subtract. So cosine pi over 2 is equal to 0, while cosine 0 is equal to 1. Then multiplying negative 3 times negative 1, it is equal to positive 3. So therefore, the integral of 3 sine x dx from 0 to pi over 2 is equal to 3. So let us have example number 3 in our last example. So we are going to determine the integral of 2 secant squared x dx from 0 to pi over 4. So in here, since we have 2, we are going to write it outside the integral symbol. And then we are going to integrate secant squared x, which is equal to tan. So we have 2 tan x to be evaluated from 0 to pi over 4. Then we are going to substitute and then subtract. So we have tan pi over 4 minus tan 0 times 2. Tan pi over 4 is equal to 1, while tan 0 is equal to 0. So 2 times 1 is equal to 2. So therefore, the integral of 2 secant squared x dx from 0 to pi over 4 is equal to 2. So that's it for now. Thank you for watching. See you again next time. Bye.